Hello friends, welcome to Awdhesh Academy, and today we are going to take the last lesson of the chapter Motion in a Straight Line. We are going to talk about relative velocity. We have all realized the relative velocity. When we are, for example, on a platform in a train, sometimes we find that our train is moving when actually it is not moving. Imagine that if there is no jerk in the train and the train is very smoothly moving, then it will be impossible for you to find out whether you are moving or the object which you are seeing, that object is moving. Only because we have jerk or we are having a smoothness, we can find out whether we are moving or the other train is moving. But otherwise, in an ideal situation, if the movement is totally uniform, we will not be able to find out whether we are moving or the other train is moving. So this is what we are going to learn today. What is relative velocity? Let us take this example. Let us see 2 points A and B. There is one particle at point A and there is one particle at point B. The position of particle A is xa and the position of point B is xb. The particle A is moving with the velocity va and the particle B is moving with the velocity vb. So we know the initial position of the particle we can write as xa0, that means the position of particle A at 0 time, position of particle B at 0 time, and this is the 0 position. After time t, if you want to find out what is the position, then xa will be using this formula xa0 plus vat, because we know that velocity into time will represent the distance travelled, and therefore the position of particle A after time t can be represented by this formula and particle B can be represented by this formula. So that means after time t, the particle A has also moved, particle B has also moved, and now suppose we want to find out as to what is the distance between point B and point A. What we have to do is that we have to subtract the two, and after subtracting the two we find xbo and xa0, and similarly vb minus va into t, and that will be the distance between these two objects after the point t. Now this particular distance, as we know, is fixed because xb and xa, this distance is already known and this is fixed, and therefore the relative velocity of these two is equal to vb minus va, and this we represent as vba equal to vb minus va. This is called the velocity of b in respect of a, and this is called vb minus va. And if we want to show the opposite side, we can say velocity of a in respect of b, then it will become va minus vb, and therefore we can see that vba is equal to minus vab. What does it mean? That the velocity of one particle in respect of other particle is opposite of the velocity of that particle in respect of our particle. What does it mean? What it means is that suppose the train is going in this direction, the other train is coming on this direction, then this particular person will see the train coming from this direction, and if we take this direction as a positive direction, then in respect of this, this train is moving on the opposite direction, and so this will become a negative direction. So even though both the people will see the train moving in the identical speed, but the direction of the two trains will be opposite. So this is why we are having VBA is equal to minus VBA. Now let us understand three different type of situations which may occur while calculating the relative velocity. In the first case, particle A is moving with a uniform velocity and particle B is also moving with the same uniform velocity, because you can see that the tangent is same. And therefore these two lines will continue to be parallel and they will never meet because the straight line never meets. Now let's come to the second situation. In the second situation, a particle A is slightly ahead of particle B at 0 point, because you can see particle A is here, particle B is here. Nevertheless, the particle A is moving with a lower speed or lower velocity as the tangent is low, while the particle B is moving with a higher velocity and therefore the tangent is higher. Here we can see that after some time they will meet each other here. In the third case, we find that the particle A is moving on minus side while the particle B is moving on the opposite side, and therefore they two will meet at some point of time at some space here. So this is the three type of situation which will come across in the relative velocity problems. Now let's solve the first problem of this chapter. Two parallel rail tracks run north-south. Train A moves north with a speed of 54 km per hour and train B moves south with a speed of 90 km per hour. Now, what is the velocity of B with respect to A? What is the velocity of ground with respect to B? And velocity of the monkey running on the roof of the train A against its motion with a velocity of 18 km per hour with respect to the train A, as it is observed by a man who is standing on the ground. Now these are the three problems which you have to solve. Let us now see this diagram. This is one track, this is north and south. Normally we represent south on the ground, means the bottom, and north on the top. So this is a north-south direction. So the first train A is running at 54 km per hour toward north, and this is the direction. So we take this direction as the positive direction. On the opposite side, B train is moving, and therefore this VB will become minus 90 km per hour, because once we take this as a positive direction, this naturally become a negative direction. So first job is to convert this figure from kilometer per hour to meter per second, and that is done by multiplying it by 5 by 18. And so this become 3 into 5 is equal to 15 meter per second. So VA becomes 15 meter per second. In the same way, if we calculate VB, it will be minus 90 into 5 by 18, and that will be equal to minus 5 into 5, and that become minus 25 meter per second. This become your VB. Now let's solve the problem. The first problem is velocity of B with respect to A. So that is VBA, and we know VBA is equal to VB minus VA. All we have to do is substitute the value, that is 15, VB is equal to minus 25, and VA is equal to 15 only, so this become minus 40 meter per second. And it is minus because it will look like it is in the direction from north to south. Now let's take the second part. Velocity of ground with respect to B. VG with respect to B. So VG, B will be equal to VG minus VB. We know both because ground is not moving, so VG equal to 0, and VB we already know that is equal to minus 25. So what we get is 25 meter per second, and this is the relative velocity of G with respect to B. Let us now go to the third part of the problem, that is related to the movement of the monkey. Now the problem is velocity of the monkey running on the roof of the train against its motion. That means its value is against the velocity of A. Now here we have taken the velocity of A as positive, and therefore the velocity of the monkey will become minus. It is minus 18 km per hour, and so if you convert that into meter per second, we multiply by 5 by 18, and this becomes 5 meter per second, and this is minus. So what we get is that VMA is equal to minus 5 meter per second. The problem now is to calculate the value of monkey with respect to ground. That means its absolute movement. So we can write that VMA is equal to VM minus VA. Now we have to just substitute the value. VMA we already know is minus 5. VM we put it like this, and VA we know is equal to 15, and therefore m become equal to 10 minus 5, 15 minus 5, and that is equal to 10 meter per second. And as you see that the value of Vm is positive, that means it is from south to north because this is the positive direction. Let us take the second problem. A jet airplane traveling at a speed of 500 meter per second ejects its products of combustion at the speed of 1500 km per hour relative to the jet plane. What is the speed of the latter with respect to the observer on the ground? So, here is a jet plane which is moving at a speed of 500 meter per second, and it is emitting a combustion material at the speed of 1500 meter per second, but that is relative to this instrument. So, let us call it A, let us call it B. So, this 1500 meter per second is the relative velocity because it is with respect to the rocket. So, we know here VA is equal to 500 meter per second. We also know VB with respect to A, that is equal to 1500 meter per second, but we can see that this is moving in the positive direction, so this will be in the negative direction. Now we know the formula VBA is equal to VB minus VA, and therefore minus 1500 is equal to VB minus 500, and if we take VB now, it will be equal to minus 1000. So we know that the velocity of B, that is the combustion material, will be 1000 meter per second in the absolute sense, that is in respect to the ground. So I hope that you have been able to understand the concept of relative velocity. We have learned about what is relative velocity, how we measure it, how we calculate it, and we have also solved a couple of problems based on this particular lesson. Please solve more problems which are given in your book, and that is the best way to get confidence on this chapter. Thank you very much for watching the video. Keep watching the video. We will be posting more and more lessons on this particular course. Thank you very much.